All right, we are here to do a video walkthrough of practice quiz number 2 for LT number 10, polynomial functions. Let's start at the top. We're going to graph. First thing I want to do, I want to look at what I've got here and check the degree. I see 1x, 2 x's in there. It's 3, 4, 5, 6, 7, 8. So this is an 8th degree, which means that both arrows are going to point the same direction. Are they going to point up or down? It's a positive a value, so I know I'm going to finish with both arrows pointing up. All right, great. Next, where are my roots? Well, where are the zeros? Here, the x in front means I have a 0 at 0. At this one, x plus 5 means I have one at -5 because -5 plus 5 is 0. This one at +2, and here at -3. Again, these values are what make our factors equal to 0. So I'm going to put dots there. 0, -5, +2, -3. Okay, now because I know it's an even degree and it's positive, I know I'm going to start from this direction. What's going to happen at -5? I see it's a 2, so it's a double root. So it's going to come down and bounce off. What's going to happen at -3? I see that triple right there. It's a triple root. So that means it's going to go through it, but flatten out and then go through. All right. Ideally, it wouldn't curve back on itself, but that's okay for now. At 0, it's just a single root, so it's just going through. And then at +2, it's a double root. See that squared right there? So I know it's going to bounce off and go like that. Finishes up, starts up, same direction. Great. On to the second one. What's our degree? I see squared, 1, 2, 3. So it's a 3rd degree. And it's a negative, so that means I know it's going to start and finish. 3rd degree, so it's going to be opposite directions. But I know it's going to finish going down. Okay, it's going to finish going down. Where are my roots? X plus 2 means we have a root at -2. And x minus 3 means I have a root at 3. So if I know it's going to finish going down, I can start like this. 3 is a single root, so it's going to go through it. And -2, it's going to bounce off because it's a double root. So it should look something like that. All right, that is standard 10.1. Let's move on to 10.2. Write the exact equation of the graph shown below. So first step is we want to check for the roots. All right, what do we know here? We know there is a root right there. There's a root right there and one right there. So if we think about our equation, it's going to be y equals a. Essentially here, we are solving for the a value. I see that I've got a root at -3, so that means my factor is x plus 3. I can see that it goes flat. There's an inflection point, so it's a triple root. I can see there's a double root at 4, so my factor is x minus 4, and it's a double root. And then I've got a factor of x minus 9 because there's a root at 9. Now, I need to solve for this a value here. The way to do this is to, just going to focus this a little bit better. Sorry, hold on one second. Is I need to find an xy point. And I can see right there, I have an xy point at 0, -2. So I'm going to replace these values. So y is -2. I'm solving for a, and x is 0. 0 plus 3 cubed times 0 minus 4 squared times 0 minus 9. That means -2 equals a times 27 times 16 times -9. So -2 equals, what does that equal? 27 times 16 times -9. -3,888a. Get a by itself. Solve for a. So if I were to simplify that fraction, I would say it is 1 over 1,944 times x plus 3 cubed, x minus 4 squared, x minus 9. Y equals. Okay? Again, this is just the simplified form of that fraction. Second one, same exact idea. Okay? We're going to start with y equals a. Now, what do I know? I have a single root at 4. So that means my factor is x minus 4 because 4 minus 4 is 0. A double root at -1, which means my factor is x plus 1 because -1 plus 1 is 0. And it's a double root. Now I can see here it passes through the point -612. X, y. So I'm going to take those values and substitute them in. 12 equals a times -6 minus 4 times -6 plus 1 squared. So 12 equals a times negative 10. Negative 5 squared is 25. So 12 equals negative 250a. Divide by negative 250. And let's see, 12 divided by 250. We can make this one a decimal. Negative 0.048 equals a. So y equals negative 0.048 times x minus 4, x plus 1 squared. That is my final answer. All right, there are standards 10.1 and 10.2. Let's move on to the back side. So for the back, standard 10.3, use synthetic division or Polydoku. We're going to focus on using Polydoku. It's much more flexible. We're going to divide x to the fourth minus 7x cubed plus 81x squared minus 65x minus 56 divided by x minus 8. So let's set up our Polydoku here. I like to draw mine nice and big. Give yourself lots of room. So on this side, I've got divided by x negative 8. Now I'm going to write what I'm going to finish with down here. I'm going to finish with x to the fourth negative 17x cubed plus 81x squared minus 65x. I'm actually going to make this a little bit bigger. Give myself more room. Minus 56. So let's break this up a little bit. And go like that. Okay. So I need to get an x to the fourth. This box needs to be x to the fourth. X times what makes x to the fourth? This has to be x cubed. Continue your area model. X cubed times negative 8 is negative 8x cubed. Now these two together have to add to negative 17x cubed. So I have negative 8. How many more do I need? This needs to be negative 9x cubed, which means this needs to be negative 9x squared, because negative 9x squared times x is negative 9x cubed. 9x squared times negative 8 is 72x squared. Wow, I wrote 97. That should have been 72. I apologize. That should be 72. All right. Now, I'm at 72x squareds. I need 81, so this needs to be plus 9x squared. So this is 9x. 9x times negative 8 is negative 72x. Negative 72x, negative 65x. I need to go from negative 72 to 65, which means I need to add 7. 7x is 7x. 7 times negative 8 is negative 56. Would you look at that? When these last two are the same, it means there's no remainder. What's our final answer? X cubed minus 9x squared plus 9x plus 7. That right there is our final answer. That's the quotient, the result. All right, next one. Do another division problem here. A little bit shorter, only third degree this time. So I'm going to make my Polydoku again. Make it nice and big for myself. 10x minus 3. I'm going to end here. 10x cubed minus 73x squared plus 31x minus 6. All right, let's set this up. 10x. This needs to be 10x cubed. Needs to match the first one here, first term. 10x times what makes 10x cubed? Is just x squared. So this becomes negative 3x squared. Again, I need these two to add together to be negative 73. So this needs to become a negative 70x squared, which means this is a negative 7x, because 10x times what? Negative 7x becomes negative 70x squared. Negative 7x times negative 3 is 21x. I need this to be a 31x, so this needs to be a 1. 1 times 10x is 10x to get. Great, those two equal 31. Negative 3. Now here's the problem. These two are not the same. That means I have a remainder. This one is not the same. Well, how do I go from negative 3 to negative 6? What more do I need to add or subtract? To go from negative 3 to negative 6, I need to subtract 3, because negative 3 minus 3 is negative 6. So my final answer here is x squared minus 7x plus 1. Now I have this remainder here of negative 3. So I write that as minus 3 over my divisor. Okay, I've got 3 more. You take away negative 3 to make the Polydoku work over whatever I was dividing by. So that is my final answer. Okay. All right, last one. Last one here. Determine all possible rational roots. Use the roots to factor the polynomial completely, and then state the value of each root for each polynomial. So my first step that I need to do is think about what are the rational roots. Okay, what are the rational roots? So for this, I have to look and say, okay, what are the factors of 27? What are the numbers that multiply into 27? So those are, as I think about it, plus or minus 1, plus or minus 3, plus or minus 9, and plus or minus 27. Now that's a lot of roots to check. All right, that's a lot of roots to check. I don't know if we really want to check that many. How do we check it? Well, we can substitute it in. So I'm going to start by checking positive 3. Hint, I already know this one's a root. Well, what does it look like? Well, f of 3, negative 3 to the 4th, plus 8 times 3 cubed, minus 18 times 3 squared, plus 27. I hope you can take my word for it when I say that that means f of 3, once we do all that, is 0. If when I plug a value in, the output is 0, it means it is a factor. So that means that x minus 3 is a factor. So I'm going to divide. I'm going to make my Polydoku here. Okay, I've got x minus 3 here. And where am I going to finish? I'm going to finish at negative x to the 4th plus 8x cubed minus 18x squared. Careful here, there's no x. But I can't just skip it. I have to account for it. Plus 0x, need to make my Polydoku a little bit bigger. Plus 0x. There's no x in our original terms, but I can't just skip it. I have to account for it by putting in 0x plus 27. Now, if I did this right, and 3 is a root, which means x minus 3 is a factor, there should be no remainder. Let's see if we can get this to work. This needs to be negative x to the 4th, makes this negative x cubed, which makes this 3x cubed. And that means this needs to be 5x cubed, making this 5x squared, making this negative 15x squared, negative 3x squared, negative 3x, 9x. That means this needs to be negative 3 because I need to cancel out the 9x, which means this is negative 3 times 3 is 9. Hold on. I did something wrong here. What did I do? What's wrong? Why is this wrong? Negative x to the 4th, 3x cubed, 5x squared, gets that. Oh, I see. Yep, this needs to be a negative 9, right? Because negative 9 times x. This has to be negative 9. Negative 9x plus 9x equals 0x, which means this is 27. So it works. Great. So now I'm here. I factored this original one into x minus 3 times negative x cubed plus 5x squared minus 3x minus 9. Okay, what's my other factor? Turns out after doing some testing, I can find that f of negative 1 equals 0, which means x plus 1 is a factor. So I'm going to do Polydoku again with x plus 1 into my cubic. Negative x cubed, 5x squared, minus 3x minus 9. Again, give yourself plenty of room. Don't crush yourself. This has to be negative x cubed, means this has to be negative x squared, negative x squared. This needs to be 6x squared because 6 minus 1 is 5, 6x. And that means that this needs to be a negative 9 because 6x minus 9 is negative 3. It works, no remainder. So now we factored it to this, x minus 3 times x plus 1 times negative x squared plus 6x minus 9. Now, my fully factored form, I have a quadratic here. I have to factor this. So if I factor that last part, it's going to factor down to be what? Negative x plus 3 and negative x and x minus 3. Okay. Negative x plus 3 and x minus 3. So my fully factored form is x minus 3, x plus 1, negative x plus 3, x minus 3. Now, what are my roots? My roots are the values that make these equal 0. X minus 3, which means I have a root at x equals 3. X plus 1, I have a root at x equals negative 1. Negative x plus 3, that's just 3. And x is 3. Great. So those are my two roots right there. All right. Hope this was helpful. Good luck.